Okay, so we're back for the second part of this video series on finding the volumes of prisms and cylinders. Let's look at this next problem. The volume of a cube is 512 inches cubed. Find its surface area. Well, what do we know about a cube? We know that a cube has sides that are all squares. So a cube is made up of 6 square faces. Let me try to make that a little bit better. Now I know the volume is the area of the base times the height, and on a cube all these sides are the same, so I'm going to call them all S. The length is S, the width is S, the height is S. So the area of this base would be side times side squared, times the height, which is also S. So the volume would be the side squared, the area of the square base, times the height. Well, side squared times the side is the side cubed. So I know the volume, 512, is the side cubed. Well, if that's true, to find the side, I have to take the cube root of S, the cube root of 512. So I have to ask myself, what cubed gives me 512? Well, it turns out 8 is the answer. And your calculators all have different ways to find them. Some of them you're actually going to see a cube root button. Some of you are going to see a button that looks like this, in which case you're going to tell it you want the cube root, and then you're going to type in 512. So you're going to have to experiment a little bit with your calculator to find out how that works. And when I get back, if you're still having trouble, I can help you out. Okay, now we're asked to find its surface area. Well, we could use our formula, lateral area plus the area of the two bases. But since on a cube, all the faces are congruent, and there's 6 of them, let's find the area of one face and then multiply by 6. Well, the area of this one face, if the side is 8, the area of this side is 64, and there are 6 of these sides, giving us a surface area of 384 inches squared. Once again, we will talk more about that idea of taking cube roots in other sections, and I can help you out if you're having trouble finding that on your calculator. Okay, sorry, having technical difficulties here. So let's try some others where I'm given the volume and I have to find other information. The volume of a cylinder is 144 pi. The radius is 3. 4. What is the height? Now, a picture is not necessary on this, but I'm a picture person, so I'm going to go ahead and draw that. I know the volume is the area of the base times the height. So I'm just going to plug in everything I know and then solve for what's missing. I know the volume. I know the area of the base because I know the radius. And I know how to find the area of a circle. I take pi r squared. Solve for h. Divide both sides by 16 pi. And when I do that, I end up getting the height is 9. So if you're given the volume or the surface area or the lateral area, your best bet, write the formula out, plug everything you know into it, solve for the missing part. Let's try another one. The volume of a cylinder is 252 pi. The height is 7. What's the radius? So I know the volume is the area of the base times the height. We were given the volume and we're given the height. I have to solve for that area of the base. So to do that, we have to get rid of the 7. Divide both sides by 7. That gives me the area of the base as 36 pi. Well, the base is a circle, and I know to find the circle, I take pi r squared, so this 36 must be my r squared, so my radius is 6. Okay, now these problems look a little strange. The first one, kind of think of it like a bolt, or I guess the nut of the bolt. And the second one you can think of like a paper towel roll. So for the first picture, we have a rectangular prism, and then in it, a circle is cut out, a cylinder is cut out all the way through. This 8 might be a little hard to read. The diameter of this circle that's cut out is 8. What I want to do is find the volume of this shape that has part of it cut out. So this is like the problems we did with areas when we were finding areas of the shaded region. You find the area of 2 parts and then you add or subtract them. In this case, it looks like we're going to be subtracting them. We're going to find the area of the rectangular prism, well, the volume of the rectangular prism, the volume of the cylinder, and then subtract the 2. Area of the prism, the volume of the prism, I keep saying area, the volume of the prism, I take the area of the base. Well, the base is this rectangle. So 9 by 10, the area of the base is 90, times the height of the prism. That gives me a volume of 360. The volume of the cylinder, once again, I take the area of the base. Well, let's see. The diameter is 8, so the radius would be 4. So a circle with radius 4 has an area of 16 pi times the height. That gives me 64 pi. So the volume of this shape with this part cut out is 360 minus 64 pi. That's an exact answer. I could definitely use my calculator to find an approximation. Okay, now we have the toilet paper roll or the paper towel roll. So I have this cylinder that another cylinder has been cut out of it. So I'm going to find the volume of the big cylinder and the volume of the small cylinder and subtract the 2. Volume, area base times height. Well, let's see, the big cylinder, the diameter is 10, which means the radius is 5, giving me the base area 25 pi times the height. That gives me a volume of 300 pi. Okay, now the volume of the small cylinder. Well, once again, I find the area of the base. Diameter is 6. I'm not sure if you can read that clearly. That's a 6. So the radius is 3, giving me a base area, pi r squared, of 9 pi times my height. Multiplying those together gives me 108 pi. I subtract those. The volume that I'm looking for would then be 192 pi. Let's try one more type of problem. So I have a rectangle situated on an XY axis. And I'm going to take this and I'm going to spin this first around the x-axis. Now, first of all, let's imagine what we would get if we rotated this thing. This rectangle would spin around the x-axis. And when I would do that, it would create a shape that would look cylindrical, like that. So imagine the rectangle, hold it down right here on the x-axis, and it spins around there. The rest of it's free to spin around. It would spin across and down to the bottom underneath the x-axis, and then back in front of the x-axis, and then back to where it started, creating the shape that looks like a cylinder. Let's look at the lateral area of the cylinder. This 3 got a little erased there. Let's put that back there. Lateral area is perimeter times the height, but this is a circle, so we're talking about the circumference when we say the perimeter. The circumference of this circle, that is the base, is going to be 6 pi times the height of the cylinder, gives me 36 pi. Now, I have this picture drawn again over here because this time I'm going to rotate this rectangle about the y-axis. So this time, this part right here along the y-axis is the part that's held steady, and this thing spins across here. So we end up with a rectangle here, and then it spins back around, giving us once again this cylindrical shape. But this time, notice the cylinder is much wider than it was before. And where the height over here for the first one was 6, the height on this new cylinder is just 3. So let's see how that affects the lateral area. Okay, the perimeter, we're dealing with circumference here. Well, the radius is 6, so the circumference, 2 pi r, is 12 pi. The height is 3. And so on this problem, we end up getting the lateral areas are the same. And we're going to look at other examples to see what does change when we take this rectangle and we rotate it in different directions. So those are our notes for volumes of prisms and volumes of cylinders. And now you're going to have an assignment to work on. So use these notes as a guide to help you out with the assignment.